Hi, my name is Leonardo Milleri. I work for Red Hat in the Virtio networking team. Today I'm going to show you how to run containerized workflows with Virtio vDPA technology in OpenShift. Okay, let's start with the demo setup. We are running an OpenShift cluster with two bare metal servers, VirtuLab 712 and VirtuLab 711. VirtuLab 712 is running three OpenShift control plane nodes as virtual machines. VirtuLab 711 is running instead a worker node directly on the bare metal. The two servers are connected back-to-back with an NVIDIA Connect X6DX dual-port card. The port on the right, ENS1F1, is included in the default cluster network and makes sure we have connectivity between the OpenShift nodes. See the Linux bridge in the picture. The other port of the NIC, ENS1F0 on the left, will be configured as a vDPA device and consumed by the application workloads. In this demo, we are going to create two pods and attach them to VFs on the same node, VirtuLab 711. But the same steps can be performed to demonstrate connectivity between two pods on different nodes. That is called internode communication. Worker node and OVS hardware offload. The main principle here is to offload the packet processing to the NIC hardware. But let's have a look in details now on how all the components fit in the picture. From top to bottom, we have the OVN controller, that is the local controller daemon, running on every worker node. It complements the existing capabilities of OVS and provides virtual network abstractions such as virtual layer 2 and layer 3 overlays, security groups, and DHCP services. It connects down to the OpenVSwitch database server over the OVSDB protocol and to the OVS switch daemon via OpenFlow. OpenVSwitch is a multi-layer virtual switch that is designed to function in virtual machine environment. The typical use of OVS is to forward traffic between pods on the same physical host and between pods and the physical networks. The OVS implementation comprises a vSwitch daemon, a database server, and a kernel data path module. The OVS hardware offloading feature is enabled in order to offload the packet processing to the NIC card. Further down the diagram we have the NIC card. It presents itself as several virtual NICs. This technology is called SR-IOV, single root I/O virtualization. So the idea behind is to allocate each VF to a cloud-native network function, for brevity CNF. The NIC is being configured in switchdev mode, an abstraction layer which provides open standard Linux interfaces and ensures that any Linux application can run on top of it. These interfaces are called port representers and they are added to the OVS bridge. Finally, to conclude, on the right side of the diagram, CNFs are bound to VFs through the standard Virtio vDPA data path. So, how does it work in terms of packet processing? When the first packet is received, packet miss, it is still handled by the OVS software, slow path. But any subsequent packet will be matched by the offloaded flow installed directly in the NIC, fast path. This mechanism is implemented by OVS and is cFlower. As a result, we can achieve significantly higher OVS performances without the associated CPU load. Now it is time to go through the vDPA demo. You can find this page a link to the recorded terminal session. All the commands here are OpenShift specific, but similar steps can be performed on vanilla Kubernetes as well. I hope you have enjoyed this demo. We demonstrated how to provision standard accelerated Virtio vDPA interfaces as a pod primary interface in OpenShift and Kubernetes. What is coming next? The idea is to provision vhost vDPA as a secondary interface in CNF and VNF. This will enable use cases like the PDK applications for user space packet processing, container native virtualization for managing virtual machine workloads alongside container workloads, and finally providing accelerated standard interfaces to confidential computing.